Welcome back, guys. Now let's just take a look at this question 7. So they say a concrete gate post comprises a right rectangular prism. So they say this is a right rectangular prism having a square base, and a what, and a pyramid at the top. So at the top there is a pyramid, and then this is a square base. This is a square, and then it's a base, as you can be able to see below. And then they said the length of the base, this one is state. We can see the height is 150. We can see the perpendicular height of a pyramid is 8. We can also see absolutely everything here in the diagram, And they also given us the formula of the pyramid, finding the volume of the pyramid is 1/3 area of the base multiplied by height, as we can be able to see. Now let's just get straight to the questions. They say calculate the volume of the concrete required to make one post. So the concrete gate that they are talking about is the full of this kind of stuff. So now they want the volume of it. So in order for us to be able to find the volume of it, we have to, the best way that I always recommend to my student is to find the area of one thing, the volume of one thing, and then add with the volume of the other thing. First, you can find the volume of the square pyramid and find the volume of the rectangular prism that there's a square base, and then you can be able to add those kinds of volumes together. You can find the total surface, the total volume of this one concrete gate. So let's find the volume. Let's find the volume of the pyramid. The volume of the pyramid. So the volume of the pyramid is 1/3, which is consists of the area of the base. What is the area of the base? Is the square that is here. The square that is here. Since you know that the pyramid is formed by something like this, let me just try to illustrate it here. As you can see, there's a square base there. So then our area of the base is going to be the square. What is the area of a square? Is the length multiplied by the length, which is 30 multiplied by 30, So then multiply by what? By the height, which is our height. What is our height? Our height here is the one that they have also told us that the perpendicular height of the pyramid section is 8, which we're going to multiply it by 8. So if you work this one out in your calculator, you're going to get 240, which is this centimeters cube. So this is 240 centimeters cube. Now let's look for the volume of what? The volume of the rectangular prism. Rectangular prism. Of the rectangular prism. So the area of the rectangular prism, we know that it's going to be length multiplied by breadth multiplied by the height. So since this one, there's the length, and the height, we're going to just substitute it. It's going to be 150 multiplied by 30 multiplied by 30. So if you work this one out your calculator, you're going to get 210. So now the total surface area, the total volume, the total volume of what? Of this post is going to be equals to what? This is centimeters cubed. It's going to be 240 plus. I made a mistake on this one. This is 13,005. This is a huge number. 135,000. So now we're going to add 135,000. This is going to be 100. I made a mistake here. I add on my calculator. Meanwhile, I was supposed to multiply. So don't mind this one, guys. So if we add this one together, we're going to get 137,400. So this is going to be centimeters cube. The reason why I always recommend my student to do it this way is that you get a chance to get the marks if you have gotten the volume of the pyramid, or maybe you've made a mistake on the volume of the rectangular prism, because when you use them all, you use that kind of formula of the total volume, there is a high chance there that you can misunderstand one value, and which is going to give you this answer is wrong. So for here, they're going to mark you for this one and also for this one. And let's say you didn't take this one wrong, you're going to get wrong on the last one. So it's always a good method to detail your work in like this. You're going to get full marks just in case you made a mistake. So we're going to 7.3. which is 7.2, I mean 7.2. So they say calculate this, the surface area of the pyramid in the section of the post. So they want an area of what? Area of a pyramid, you know, area of a pyramid. Area of a pyramid. Okay, yeah, I tried to write it there. So what is the area of a pyramid? Remember, when we talk about the area, I've made a video, guys, on this playlist. If you can go and check it, I think it's the second video whereby the difference between an area and a volume. When we talk about an area, we talk about the outside parts of what of this thing. So the one, the area of the pyramid, we talk about the outside part. We don't include the base actually on this one, you know. We talk about what the outside part. Why we don't include the base? Because on this concrete gate, we don't see the base of the rectangular prism. Do we see it? No, we don't see it. We just see what? The outside part. So in order for us to calculate the surface area of the pyramid, what do? We have to calculate the areas of the triangles that are there, which are 4 of them. So we're going to calculate them. How many triangles are here? It's going to be 4, which are going to say half base multiplied by what? By the perpendicular height. After this, we can be able to get what we need. So it's going to be 4 half. What is our base? Our base is going to be what? 30, obviously. But what will be our perpendicular height? So for our perpendicular height, we have to calculate it. Remember, this thing it has done like this. It has 8 here, which is 8 centimeters, and then the other side there is a triangle. There's a right angle triangle that can be able to be formed, that can be able to help us to find what? To find the perpendicular height, you know. So the perpendicular height is something that can be able to be formed here, which is the radius of what? Of the right angle triangle that is there inside, you know. So since here is 8, so the distance between here to this particular side, which is here, and then it's going to be half of this 30, which is going to be 15 centimeters. So guys, we've been doing this on our previous videos. If you have watched my videos whereby I teach the basics, always on the rectangular, on the pyramid, we have this right angle triangle is there that can be able to help us to find the perpendicular height. If you haven't watched it, please go and watch it. It's going to help you to understand what we're talking about here. So if we find the height of this one using the theorem of Pythagoras, then we can be able to find what? We can be able to find our height that we are looking for. So let's just aside, you have to also show it. How did you get that kind of height? So you have to show them that this is the theorem of Pythagoras, which x squared plus y squared. So our r here on this thing is what we are looking for, which is our r is the radius, the hypotenuse. We are looking for it. So it's going to be r squared, which is equals to, and then the x is going to be 15. How did you get this? 15 is the half of 30 squared plus the 8 squared. Then we're going to put the square root, and then our r is going to be equals to what? It's 17 centimeters. So our perpendicular height there is going to be equals to 17 centimeters, you know. So for this one, we're going to have what? We're going to have multiplied by 17 as our perpendicular height. So if you work this one out in a calculator, you're going to get 1020 centimeters squared. So now we're going to the last question. They say if the length of the side of a base is half the, so they say this size of the base, which is the base, is a square. They say if this one is half the, how many posts having the same design as the original can be made with the same volume of the concrete as the original post? So this question can be a little bit confusing, but it's very easy. It's very easy. So for now, this rectangular prism of ours, let me just try to redraw it here. Maybe you can be able to see it here. Yeah? So this rectangular prism of ours right now, it has been halved. The side of a base, which means here is going to be 15, here is going to be 15 also, and also here is going to be 15, here is going to be 15, but this one remain 150 centimeters. Now, so they want to know the volume of the new design that it can be able to for it. In other words, they want the volume of this one. They want to know the volume of it. So if you want to find, this is 7.3, né? If you want to find the volume of this one, we're going to do what? We're going to say, this one is the volume of the whole concrete, the way that we have done it here. We find the volume of the pyramid and add it with the volume of the prism. So now we're going to do it together because we are running out of time. So we're going to say, what is the area of the top part? Is going to be, the area of the top part is, the volume of the top part is half base multiplied by length and blah blah, those kind of stuff. It's going to be 1/3 base multiplied by base, which is multiplied also by the height, you know. So this is the first one of the volume of the pyramid, and we're going to add it with the volume of what? Of the rectangular prism, which is length multiplied by height. Since this one is the square base, all these are the same. This one is the only one that is different. So now we're going to look for this kind of a new volume of this thing. We're going to say 1/3, and then base is going to be 15 multiplied by 15 multiplied by height. The height of the square pyramid, you know, the half of the square pyramid is still 8, you know, so it's going to be 8 here. Let me just write this one clear. It's 1/3 15 multiplied by 15, and we're also going to multiply by 8 there. So this one will give us the area of the pyramid, the top part, which is the 8 here. Since note that anything has not changed, the thing that has changed is the bases. They have been halved. It was stated it goes to 15. So plus what will be the area of this one is going to be 15 multiplied by 15, but the height remained the same as 150, which is 150. So if you work this one out in a calculator, you're going to get 34,350 centimeters cubed. You know, so this is the volume of what? Of this one post. So the question here, I want to know how many of these posts that is here, how many of these posts that can be able to be designed as the same original that can be able to be made with the same volume of concrete as the original post. In other words, let me just first do this question in this way so that you can be able to understand. Let's say we have a square, which is this one. Maybe you will understand this question very easy. So let's say this square, it has a 10 centimeter and also 10 centimeter. So now let's say they say that they have this kind of a square. So if they have it, is going to be like this, and they also have it the other side like this one. So here is going to be 5, and here is going to be 5, and here is going to be 5, and there is going to be 5, you know. So let's say for the first time they ask us about the area, you know, of the bigger square. The area of the bigger square is 10 multiplied by 10, which is 10. I won't use the volume because this is a 2D dimension. So this one is going to give us 100. So what will be the area of one square that has been formed after we have half the base? The area of the half of the square, which is half of the square, is going to be equal to what? 5 multiplied by 5, which is 5 multiplied by 5, you know, which is give us 25. You know, so let's say they want to know how many of these squares that have been formed there. They want to know how many of these that have been formed as the same design as the original. How many squares that are the same as this bigger one, you know. By visual, we can see that this is 1, 2, 3, 4 of the squares that have been formed here if they have the base. If they have the base as what? As 5 and 5 there. So the area of the, how many of those kinds of squares that they can be able to pick is 4 of them, you know. So, but how did they get that kind of 4? Is that they have compared the areas. They say that the areas of this, of the bigger one is 100, you know, it's 100, which is the bigger one. And they divided by the area of one of these thing here, which is 25. If you work this one, we're going to get 4 centimeter. We're going to get 4 of the squares that have been formed here, you know. So in order for you to be able to know how many of this type of shape that have been formed from, that is the same as this, when you have the volume like this, you just have to compare the first volume that you have got here. The first volume, it was 137/400. So we're going to say, to find the how many to find how many posts that have been formed. We're just going to say what? We're going to take this one, which the volume of the original, which is 137,400, and we divide it by what? We divide it by the volume of one of these things that we have found here, which is 34,350, you know. So if you work this on your calculator and you plug it, you're going to get 4 of what? Of the poles that are going to be created here. So this question, it has 2 marks. Why did they do so? Yeah, but this is how to answer this question. So see you on my next video. Sharp.